Hey, welcome to Unit 4. All right, we finally made it. We're at one of the last units of the semester, which is kind of crazy. It's already November, so this unit is going to be about transformations, okay? And we're actually going to talk about our first transformation today, which is a translation. Since this is the first lesson of the unit, we are going to start with some vocabulary, but we're actually going to get down to some doing some examples today. So the first thing we're going to talk about is a rigid motion. All right, what is a rigid motion? It's kind of a weird definition. A rigid motion is a type of transformation in which your image and pre-image are congruent. And think about what congruent means, okay? Congruent means they're the exact same. Okay, so rigid motion is a transformation where the shape doesn't actually change, just its position changes. Okay, so we talked about the image and the pre-image. The image is what you have after you do your transformation, and then obviously the pre-image is what you originally have. So we're going to study three types of rigid motions in this unit. All right, obviously the first one that we're going to study is a translation. But then we're also going to study a reflection, and we're going to study a rotation. Okay. So today we're starting with translations. Translations, I think, are the easiest ones. A translation is just a shift. Okay. That's literally all it is. You're just moving it around. Okay. So for example, all right, we have a shape here. We want to translate the figure 3 units to the left and 5 units up. Okay, 3 units to the left and 5 units up. And literally the way that you're going to do this is you're just going to count. All right, so I'm going to start at R. I'm going to go 1, 2, 3. And then I'm going to go 5 units up. 1, 2, 3, 4, 5. So this is our new point, all right? And we're actually going to label this R prime. Okay, that's how you can say it's been transformed. You put a little apostrophe up there, and we just pronounce that prime, okay? And we're going to do this with every shape, okay? So we're going to do this with S. We got 1, 2, 3, 1, 2, 3, 4, 5. And it's important to label your shape. So we've got S prime, T, 1, 2, 3, 1, 2, 3, 4, 5. There's T prime. And then finally we have U, 1, 2, 3, 1, 2, 3, 4, 5. And that would be U prime. And once you've got all your points, you can connect them. And you should be able to see, okay, we've now shifted 3 units left and 5 units up. And if you look, you should notice that the shapes are congruent, right? So if we did the distance formula between, this side right here, TU, and TU prime, right? The sides would have the same length, okay? Because we didn't change any of the side lengths. So that's why it's a rigid motion. So we're actually going to write a rule for this transformation, okay? Translation rules are pretty easy. You take all your points, right? Points all have an x, comma, y coordinate. And you just say, how are we actually changing them? So 3 units to the left, all right? Left to right, that's your x-axis. And going to the left on the x-axis is getting smaller. So our x-coordinate is actually, getting smaller by 3. And then it's going up or down is y, so it's going up by 5, so the y value is increasing by 5. So our rule is that all points are going from x comma y to x minus 3 comma y plus 5. And so you could actually, take any point you want and plug its coordinates in and get its new coordinates under this rule. But counting is just easier, but it's still important to see how the rules look, because I could give you a translation with a rule and you would have to fill it out. So this is what the generic form of what we just talked about looks like. So this means that if a point in the pre-image is given by the coordinates x, y, so remember this is our pre-image, and then the corresponding image is shifted h units to the right and k units up, all right? And so that's why we had a negative number right here, because we were going to the left. So that's kind of how this works. So we've got our pre-image right there, and then after our transformation, that's our image. And the way that it's labeled is with primes, that way you kind of know. So we're gonna do a couple more examples here, all right? So number 1, describe the transformation given by x comma y using words. Okay, so think about, so we have x plus 7, all right? So the way that's gonna look, the x value is increasing by 7, so that means to the right 7, and then y minus 8, that's gonna be down 8. And that's it, okay? So it's important to be able to read these, because I might give you questions where I give you this, and then you have to do the translation. Write the coordinate notation for a translation that shifts a point 2 units to the left and 11 units up. Okay, so we've got our x comma y. All right, and when it says coordinate notation, it's just talking about like this. So you always start with your x comma y, because that's your original point, and then it changes how? So 2 units to the left, so x is going to the left, so it's x minus 2, and 11 units up, so that'd be y plus 11. Describe the translation shown in the graph using words. Okay, so let's look at our one. So again, you should be able to tell which one's the pre-image and which one's the image. These are the ones with the primes down here. So this is the image. So this is our starting value up here. So how is A changing? Well, we can count, right? 1, 2, 3, 4, 5, 6. So it's down 6 and over 1, 2, 3. So right 3. So in words, we can say our transformation is right 3 and down 6. And so in coordinate notation, how is that going to look? Well, we're going to have x comma y. We're going to the right 3, so x is increasing by 3, down 6, so y is decreasing by 6. And so that's kind of how that corresponds there. You're more than welcome to try these on your own too. And then, pause the video and then come back and see the answer. I don't think these are that difficult. Complete the translation described below. So sketch the quadrilateral RSTU. So first, so here's RSTU right here. So we need to sketch these points. So we got R, that's at -4, -1. All right, so there's R. We've got S at -2, 0. Wow, this is going to be close together. We've got T at -1, 3. And we've got U at -3, 2. Okay, so for some reason, we have this tiny little quadrilateral. I'm actually going to make my line smaller. Okay, so let's look at our style here. Okay. So now we want to sketch the image after the translation, x plus 4, y plus 2. So what's happening? All right, it's going, x is increasing by 4, so it's going to the right 4, and then it's going up by 2. So we need to count all our points. We need to go to the right 4, so let's do T first. We got 1, 2, 3, 4, and then up 2. So there's t prime, okay? Oops. U, 1, 2, 3, 4, 1, 2. So there's U prime. S, 1, 2, 3, 4, 1, 2. There's S prime. R, 1, 2, 3, 4, 1, 2. Cool. Now, does that look the same? It should. Looks pretty much the same to me. All right. Forgot to say, oh no, I'm good. So we've labeled all our coordinates correctly. We translated it. So what can we do now? Now it wants us to list the coordinates of the image. So we could just look at our graph, all right, when we counted, but we can also use our rule here to figure this out. So all we're doing is we're adding 4 to all the x values and adding 2 to all the y values. So if we look at r, okay, -4 plus 4, that's 0. -1 plus 2, that's 1. S, -2 plus 4 is 2. 0 plus 2 is 2. T, -1 plus 4 is 3. 3 plus 2 is 5. And U, -3 plus 4 is 1. And 2 plus 2 is 4. So those would be all our new images. So you could, if you wanted, get all the new coordinates and then just place the new coordinates instead of counting. But I think counting is a little bit easier. Last one. The transformation xy is x plus 4, y minus 1, okay? The okay, wait, sorry. That's t onto t prime, okay? That's important. Then the transformation xy to x minus 7, y plus 3, that's t prime onto t double prime. Wow, so we're doing a transformation on our transformation. So it says, write the coordinate notation for the transformation that maps t onto t double prime. Okay, so this is kind of cool, all right? So you can actually do multiple transformations. So we're really shifting these points twice, right? So we've got 2 transformations. Let's look at what happens. Okay, in the first transformation, we've got x plus 4. But then we're taking that and then we're subtracting 7. So we've got x plus 4 and then minus 7. If we look at y, we've got y minus 1. And then we've got y plus 3. So we've got y going down 1 and then going up 3. So if we combine those transformations into one transformation, what is that equal to? I guess we could say it's equal to, so if x is going right 4 and then left 7, 4 minus 7, that's -3. So it ends up just going to the left 3. Then y is going down 1 and then up 3, so -1 plus 3 is 2. So y is going up by 2. So that would be the new transformation. So this is translations. There's a lot we can do with this. It's not the most exciting one, though. Reflections and rotations are a bit cooler. This one's just kind of moving it around. But so if you're a B group, right, and you watch this, the way that it's set up, so you should be watching this on Friday, okay? We're splitting it up for you, not giving you too much to do in one day, all right? You're watching this on Friday, and then on Monday, you're going to do the practice that goes with this. Can you do the practice right now and get Monday off? Sure. Can you do the practice, on Sunday? Sure. But by Tuesday, all right, you need to have completed the practice by the time you come into class. Because on Tuesday, we're doing reflections, all right? That translations, we're just having you do at home because it's not that difficult. But reflections and rotations, you're going to do in class, okay? So if you have any questions, let me know. And have a great weekend.